into part 4 of your guys' notes. We are going to compare unit rates. Remember in your guys' definitions that we said that a rate was comparing two different quantities, and a unit rate was a rate that had the denominator of 1. So our first example is we have Mr. Marshall is driving. He drove 100 miles in 2 hours. Mrs. Wilson drove 60 miles in 4 hours, or 600 miles in 4 hours. And Mr. Vanzel drove 200 miles in 10 hours. Who drove the fastest? Well, the way that we can figure this out is by writing rates and then finding the unit rate. So the rate for Mr. Marshall is 100 miles in 2 hours. His unit rate would be then 50 miles in 1 hour, because all we did was we took 100 divided by 2. Okay. Mrs. Wilson did 600 miles in 14 hours. So all we did was divide, and I got a nice little decimal. So I got 42.8572. And how do we change that into a fraction? Because I think fractions are a little bit easier to compare when it comes to miles. It gives you a little bit better idea. So if I have this calculator right here, I can take 600 divided by 14. And that gives me 300 over 7. Or again, that really doesn't tell me very much. But what I could do is, you see how this says it as a fraction and it turns it into a mixed number? That's exactly what we want to do. So I'm going to hit the second key and then hit this key. And that's going to tell me that she did 42 and 6/7 of a mile in 1 hour. If you had this calculator and we take 600 divided by 14, you came up with a decimal. How can I change a decimal into a fraction using this calculator? Well, it's really actually handy. I can take the second key and hit the arrow key. And if you see the dash, that means that is a whole number. The number to the left of it is a whole number. So this is 42 and 6/7. The exact same thing, just different ways of actually getting it. So Mrs. Wilson drove 42 miles and 42 and 6/7 of a mile in an hour. Mr. Vanzel drove 200 miles in 10 hours. So how many miles did he drive in an hour? Well, 200 divided by 10 is 20 miles per hour. So who drove the fastest? Mr. Marshall did. He did 50 miles in 1 hour. Again, when it comes to your homework assignment, if you were to just show me all your work, but you didn't tell me that Mr. Marshall drove the fastest, you counted wrong. Okay, not totally wrong, but you would lost at least 1 point. So looking at the next example that we have a dogwood tree that grew 6 feet in 10 years. We had a snake plant that grew 2 feet in 7 years. We had a butterfly bush that grew 4 feet in 8 years. Which grew the fastest? So in this case, what do you need to do? Isn't this very similar to the previous example? Yeah, so what did you have to do in this case? You had to divide them. So the dogwood tree, I took 6 divided by 10. 6 feet divided by 10 is going to give me 0.6 feet in 1 year. The snake plant did 2 feet in 7 years. Well, again, this one, it might be a little bit better to use as a decimal. That way you can compare a little bit more clearly. We have 0.285714, and it just continued on. 2 divided by 7 is going to be a repeating decimal. Not a repeating decimal, it's just going to be an extremely long decimal. I apologize for saying repeating, because it's not. And then I rounded. Okay? So I rounded to 0.3. Why is this going to be 0.3 feet in 1 year? Well, I rounded to the tenths place. So looking at the hundredths, it's an 8. And remember the rounding rules, it says that if it's 5 or greater, you do what? You round the number up. So since 8 is greater than 5, I rounded the 2 to a 3, so 0.3 feet in 1 year. And then looking at the butterfly bush. The butterfly bush grew 4 feet in 8 years. So how many feet did it grow in a year? It grew 0.5 feet in a year. So which grew the fastest? That's when you got to realize your decimals. Which has the bigger decimal? The dogwood tree grew the fastest, because the dogwood tree grew 0.6 feet in 1 year. All right, so now I want you to try out this problem. I'm buying peanut butter. Let's say I went to Walmart. If I'm buying peanut butter at Walmart, there's a couple options there. Let's say these were the options. Let's say there was a 64 ounce of peanut butter that was for $3.20. And you had an 8 ounce of peanut butter that was for $1.50. Which one's the better buy? So I want you to pause the video right now, and I want you to solve this. Which one is the better buy and why? Good, assuming that you guys have paused it and have worked it out, you would realize that you would have to divide money by ounce, because I want to see how much each ounce costs. So $3.20 divided by 64 is going to be 0.05 an ounce. So every ounce costs 5 cents, whereas on the 8 ounces for $1.50, I take $1.50, divide it by 8, and I come up with 0.1875. Well, that's about 19 cents per ounce, isn't it? Again, all I did was round on this. Since I'm talking about money, I went around to the hundredth spot. So I had to look at the 7. Since it was 5 or greater, I rounded the 8 to a 9. So which one is the better buy? Well, do you want to spend 5 cents for an ounce, or do you want to spend 19 cents for an ounce? I want to spend 5 cents for an ounce, honestly. So the better deal was the 64 ounces of peanut butter for $3.20, because each ounce only cost 5 cents. Okay, that concludes part 4 of your guys' notes.